Hi. I got thrown out of the main building, so I'm back home at the command center here. I also have a little friend here with me. I'll probably get rid of him in a second. So um, don't worry when he starts squawking. so t- we're making a big shift today. So this week is still all Zoom meetings, so we're going to do the same morning, afternoon recitations over Zoom like we did last week. This is, of course, still based on the campus circuit breaker and the debate, which is Wednesday. And I would urge you to at least participate in some of the attention that the U is getting and take a look at the debate and see how they portray campus and the city and the state and stuff like that. All right, so Java so far, we've been doing a lot of stuff with like little methods, and the idea is to exercise your problem solving skills. Again, there's sort of two main parts to programming. One is picking up some of the technical understanding of how whatever programming language you're using works, and the other is to exercise your problem solving skills. So basically, you know, as you progress as a developer and computer scientist, it's not like you're going to be asked to do the same thing over and over again. You're going to be asked to solve new problems in new contexts, and you know, um, part of being a good developer is having the ability to solve these kind of problems. So we've been working on that problem solving skill, and also hopefully picking up some understanding of how some of these basic Java constructs work. But I'm going to say, so far we have not really been using Java in the way that Java is intended to be built or used. So today we're going to learn a little more about sort of the style of programming that Java is best suited to support, and that is object-oriented programming. So what we've been doing so far is this, procedural, what we sort of call procedural programming, sometimes functional, which is a little different. And the idea is you break big problems into little problems, and then at some point you sort of understand how to solve those little problems, and you combine them all together to solve that big problem. And there's some advantages of writing methods, or sometimes in other languages called functions, where you basically hide the details of how that works inside the function, and you can call it and have sort of a whole bunch of stuff happen and get some answer back, and you control how information flows from, you call a method and pass it information, and maybe it calls other stuff and passes information, and then information comes back through the return values. Now, one thing that's a bit of a problem is that, okay, if the cat's just going to sit here and take a little bath, I'm going to get rid of him. Say goodbye, Geyser. Okay. Doesn't look too happy. Let's see if he forces his way back up here or not. Part of the problem is that we have to understand the connection between the data that we're passing around and what's going to happen to it. And sometimes that's not totally clear. So for example, here is a method moon launch and has various parameters: crew count, fuel, weight, come back, food. And some of these, int crew count. You can probably guess what that means. There's 3 astronauts or something in the rocket. Fuel, what are the units? What is that supposed to mean? And you have to be very careful to make sure that you're using these methods in the way that they're supposed to be used. And you do that by, for example, reading documentation and comments and things like that. So, and that's it's up to you in some ways to use that properly. Object-oriented programming tries to make it so that the operations on the data are a little more clear and connected. So there are objects that we build in object-oriented programming, and they basically combine the data side with the procedures into one thing that are sort of, it's more tightly coupled, more linked. Whereas, just a method here, it's not as clear. We can pass whatever we want in there, and there's no like enforcement of how we use it. We just have to sort of work to do it correctly. With object-oriented programming, they're sort of built into one thing, so it's sort of harder to misuse. So when we do object-oriented programming, we're going to write class a class, which we've been doing, but not really using the class as an overall structure. And that class defines a new type in the system. So for example, we saw how the picture class defines a new type, and we can make variables of that type, make instances of that type, and that those new variables hold these objects. And then we ask the objects to perform tasks for us, kind of like calling a method, but again, it's more like the object knows what it's doing. So we've used a number of standard Java objects like scanner and file and arrays and strings. And we've used these objects defined by others, picture, and we're going to start defining our own objects now ourselves. So again, I think it's one hard thing about object-oriented programming is getting this mental model down correct of what's going on. So in our prior style, we had data that we'd pass into a function or method, and coming out of that thing was some sort of change data, and we would link these together into some set of operations to kind of get to some final answer. With object-oriented programming, you have an object, so some new type, and in that object is some stored data and some method that belongs to that object that knows how to work on that data, and it basically provides some changed data to us. Sometimes it just changes the data inside it, and then eventually we ask for it, but sometimes it provides it coming out. Now, I kind of think of this a little differently than procedural style. Like these objects, you sort of, I don't know, they're like little things, little friends, and you talk to them. You say, hey, make me a picture that's gray, and it does it, And so it's this anthropomorphic style where you're sort of interacting with entities that aren't, I won't say like that are intelligent or anything, but they have a bunch of behaviors, and you sort of ask them to do things. And that's a little different, I think, than having a bunch of methods that you just sort of are like tools in a toolbox, maybe, right? So that to me is sort of the mental difference between these two styles of programming. Now let's compare sort of, not even knowing what this does yet, but just sort of compare a style of programming this stuff. So in the procedural style, we might have a bunch of variables all related to one particular person, right? So name 1 is Jane Doe, lives in Denver, and city 1, state 1 is Colorado, age 1 is 30. And then a second person would have to have name 2, city, state, age, and so on. And maybe those could be an array of names, an array of cities, an array of states, and so each person takes up a similar spot in those arrays. But the only thing that keeps those together is sort of our own organizational skills. And then we can use those variables in a call to a method. And I purposely here made this the wrong one, right? I sort of was copying and pasting. And so again, it's our responsibility in some ways to understand that these are related and to use them in a related way, but there's nothing really enforcing that. In contrast, let's say we define a new type that's a person that holds these pieces of information. We may create this new person with those sending in as parameters or arguments to that new type, these values, and this P1 object knows about those 4 different things. 1, 2, 3, 4 things, yeah. And we make a second person, and these are all connected. But notice there's no way to kind of scramble up the name of this person and the state of this person. They all belong under one variable here. So they're sort of, again, tied together a little more closely. But it's not just that tying together the data. We're also going to define some operations, some methods that only work on that data that's inside it. All right, so there's 2 terms that come up a lot, and there's more terms to object-oriented programming, but ones that I want you to think a little bit about is this idea of encapsulation. And again, that's where we hide and connect together data in one object. And we basically are going to control access to the data through code. So you can't just sort of go and start changing where I live without sort of requesting that from the object. And the idea is we want to disconnect how other code works with us. If they have a variable, that person type, they can interact in a certain way, but they can't do anything they want. And then another one is abstraction, which we've been talking about before. And again, basically, If you have a well-named method, you can use it without understanding all the details of what's going on inside the method. So for example, if we have a birthday method, maybe it adds one to that internally stored person age, and maybe it has a whole bunch of complicated stuff, like if their birthday was on leap year, May 29th, how do you calculate their birthday? But if you just do a good job saying like, what the method's called, then we just sort of ask that thing to work on it, and it handles like the messiness for us. But it's sort of the same thing as we've been doing with methods already, but it's still an important part of object-oriented programming. All right, so basically to make one of these new object classes, we define a class like class person, and in there we're going to declare some data that the person knows about, and we're going to declare some methods that work on the data. And then in main, we basically make or some other code, doesn't even have to be in the same class. We make instances of the class to use as variables. So similar, like we had the picture class, and then in our other code, we said picture1, or gray picture equals a picture of some kind, and the bright picture equals a picture of some kind. Each of those were independent objects. But let's work on this and see how it works. All right, so here we have, let's see, somehow the first thing to notice actually is the name of the file, person.java, has to match the name of the class. And that's been true all along, but we haven't really worried about it. So I just want to make sure that's clear. Let's see, maybe I need to, okay, that seems fine. So this defines the class, and it's public, which means other classes and other files can see this and use it. Only rarely would you have a private class. The keyword class, and then the name of the class, capitalized. That's the standard here. And then, let me just make sure I'm kind of where I want to be here. Typically then what we do is define what data, when you make an object of this class, what data is going to be available. And let me just kind of type this out and talk about it. So we have, these are called instance variables. And they are not inside a method, right? They are floating around by themselves, but they are inside the, oh shoot, I'm sorry, I'm already doing this kind of wrong. This main is not necessary yet. All right, so we're not defining it inside main. We're defining it inside the class scope. So here's the curly braces for the class, and these are just floating around inside there. So I'm defining several things that a person is defined by, and in some ways this is not an obviously comprehensive list of things, but name and age and maybe where they live. Maybe this is some kind of person class for voting records or something like that. And when you make a variable of type person, then this object, me, has its own storage for each one of these things. So there's a me name, David, me city, Salt Lake City, me state, Utah, me age, 12. If I made another person object, that would have its own storage with a different name, a different city, different state, different age. All right, so these are two different things. Each has their own copies of these instance variables. Private basically means that only code in the class, so in this class scope, can access that thing directly. And again, this is to protect these from other code that may change it when they shouldn't. So for example, if someone else had made a person in a different file from me and went and changed the age to be 100, they maybe don't have the rights to do that, or you don't want to give them the right to do that. And so we make this private where only code in here can manipulate these values. Okay. And let's look at one thing here. How do we access these things from here? Like, how do I get to my age? Well, use that dot notation. So this says, tell me the age belonging to the me object. If I run this, 0. Notice I didn't have to initialize these. These are default initialized to sort of zero state. So the age is 0, not an undefined thing like we'd get with a method if we didn't initialize this to anything. Okay, so normally when we build an object, we don't want to just have some default thing filled with default values. We want to give it some initial set of data that it can use to build up this object. And those are done using special methods called constructors. Only has one capital letter. And in there, we first make it public because we want other code to be able to make examples, instances of this person class. And I give it the name of the class, which is a little funny, right? Notice there's no return value. This is not, it's not even a void thing. This is a constructor, it's a special thing that basically defines how a new object is made. And I give it some parameters here. And this part, to be honest, is often kind of seems a little like redundant. You're passing in 4 values because there's 4 different instance variables, and I'm basically just assigning them. So I'm saying name, this instance variable gets assigned the value I send in here. And city. So it's like, this is kind of brain dead code. There's nothing interesting going on here at all. It can be more, you can do computations to set up your object. Okay, so what's the flow of things here? So first of all, this no longer exists. This was called a default constructor. And in this case, there is no person constructor that has no arguments. Now there are 4 arguments here. So I would have to, David, what are we doing? City, Salt Lake City, Utah, and oops, and that's an int, not a string, and 12. You, Sally, lives in Boulder, which is in Colorado. Sally's 35. And I made that a string again. Okay, so what's the flow here? So we run main, it says, hey, make me a new person and assign it to me. And in this new person, this argument gets sent to init name. This gets sent to init city, and so on. In the constructor, I am saying that init name gets assigned to name. Now here's the thing, and really one of the main defining characteristics of this object-oriented style. Normally when we have something that looks like a method, what variables are in scope? Well, normally there are the parameters like init name and any local variables that we define inside here, like int money, I don't know. And this can all be used in the scope of the method. In object-oriented programming, when this is not a static method, notice I didn't use static here, that means it belongs to instances of the class. We can also use the instance variables of the class. So anything that's defined up here, well, in the scope of the class, that name we can use here as well. Okay, so I think it makes coding a little bit more complicated sometimes because you're sort of wondering, you're going along reading this code and you're like, okay, init name, person, blah, 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 name. And you're like, where did that come from, right? Like, I don't see it defined here. And you have to remember to kind of look up and find those instance variables and see that it's part of it. Now, normally when you're writing the code in the class, you're very familiar with all these instance variables, and it's not like a surprise or anything like that. But when you're looking at some other code someone else wrote, then it gets a little more confusing. So to be careful of that. Now, I'm going to add another constructor, and this one again has no parameters, takes no arguments, and is often called the default constructor. And in this case, we are going to just provide some default values that make sense for this object. Now in this case, I'm giving it a name, but I'm leaving the age default initialized to 0. Often you don't do anything at all here in the default constructor. You just let everything just sort of be sort of the default values that get assigned here. But you don't necessarily, you don't need a default constructor, but there are places where it can be useful. So if I had this here, and then I could make person objects in two different ways. One is by passing in all the information, and the other is to default construct it where it just gets some default value here. Now it's a little weird that we have what looks like methods with the same name, and normally that's a bit of a problem. But you can do something called overloading methods, and when you overload a method, it has the same name, but it has different parameters, right? So either the types or the number of them have to be different. And in this case, the compiler can tell the difference. If it sees you calling a method that has these 4 values, it looks for a method that has those 4 parameter values. And if it match up, it can call it. If it calls it a different way, it says, well, that doesn't match here, but it's a match here. And so it can figure out which one it belongs to. All right, we can do this outside of this object-oriented programming. So over here, I'm doing a static method, again, one that doesn't really belong to any object of that class. And I'm summing up 2 numbers. And here I'm summing up 3 numbers. And same name here, but different number or type of parameters. And that's allowed. Again, if the compiler can tell the difference between them, it's okay. Now what you can't do is, for example, say public static int sum int x1, int x2, and then try another one that's public static double sum int x and int y, because those are the same, that would be the same parameters here, different value coming out, and doesn't know which one you really want to use there. So it's the parameters that have to be different. The name can be the same. All right, so I've made a beginning class here. Every instance, in other words, every variable I make of person type, first of all, has to be created with new, and I decide which kind of constructor I want to call. But now this me has an age, and if I try to call age on you age, those are 2 different storage things, right? Those are 2 different places. There's a whole collection of storage for me with all those different values, and a whole collection of values for you with those different values. And so here, the dot age was 12, because that's how I constructed it. For the you age, it was default constructed, and the default value is 0 in this case. But the important thing is here, notice this is not, I'm not making like saying how one thing works. I'm saying how a whole bunch of things work, and it's the variable that that is being used that defines which age is being used. So again, an object is an instance of a class. So this is the class definition, and an instance of it is like an example of it. And a variable of an object type holds a reference to wherever this thing is in memory, right? So again, it's not really holding it directly. It says, I say, I know where this whole thing is being built, and I store where it is as a reference in this variable. So U holds a reference to where this thing is, me holds a reference to where this thing is here. When you make a new person, again, that's going to go on the heap somewhere. And there's storage for each one of these instance variables stored on the heap. Place for a string, place for a string, place for a string, place for an int. And again, the strings are actually references to somewhere else on the heap, right? So you can declare a variable of some type. You can assign a new person to that type, or like we do with most variables, we can declare it and initialize it all at once. Now, I kind of briefly mentioned these things here, private and public, are called access modifiers, and they define where this code can be used in some other part of the project. So public means any code in any class can get to it and basically call that constructor. Private is only used in the scope of the class that defines it. Notice this main here is part of that class scope, so that's why I can get to age here. If I was in some other file, some class, I don't know, voting record or something, I can still make a new person because the person constructor is public, but I could not directly access these instance variables through this dot notation. Okay. So public used in any class, private used in a class that defines it. We usually make these instance variables, sometimes called the member variables, private. And we don't want to let other code just necessarily go in there and change the age without us knowing about it, right? So we're going to control access to these things through code in our class. So I want to do some examples of showing that. So here we have the instance variables. Here we have constructors. I'm going to define let's do a getter first. And a getter is public string get name, and it doesn't have to be called get name, but it's sort of a common way to do this. And all this thing is doing is pulling out that name value. All right, so let's look at this. Public, that means other code can use it. This thing returns a string. Notice it's not public static because it's a normal method, not a static method. It means it has to be called from an object of the class, and I'll show that in a second. Get name. I'm not passing a string in that's sort of like the name because an object already knows its name, and we just say, hey, let's tell the world what my name is. So like down here, I am going to call from an object, from me, I'm going to call get name. All right, so notice I'm not passing in a name here. It's not like get name David. That wouldn't make any sense, right? I'm asking, it's like you say, hey, what's your name? You don't say, hey, what's your name? Tell me Sally, right? You just say, what's your name? And I say, my name is David. So here I'm asking this object what its name is. It goes up here. What name does it use in this case? It uses the name associated with the object that called the method. So me called get name, and it is the David name that is returned here. If I did this with you instead, it would say you calls this method. What is the name stored inside the you object? Well, we did a default construction of you, so it was John Doe that is the name associated with it. All right. So notice there are two different versions of ages and two different versions of names, one associated with me, one associated with you. But when I call getName from an object, that is the object's data that gets used in this case here. Okay. A setter does the opposite thing. The job of the setter is to change that stored value inside the object. So here I'm going to actually give it a new name, and I'm going to assign to the name associated with the object that called it that new name. Okay, so how does this work? If I were to call me set name, and I'll call it King, I'm now King David. I got a promotion of some kind. And then I print out the name associated with me. I'm going to comment this out here too. Okay, so I make a person and assign to the name associated instance variable for me, David. It's assigned to the name instance variable. I'm printing out my age. I'm getting the name. I'm now setting the name to a new name and printing it out. So printed out the age, printed out the name, and then printed out the new set age. So here's the thing here, look. I'm not returning a value out of this thing, right? You might think, oh, I should return a string, because that's what normally you change something and then that change thing comes out. In this case, I'm passing a name in, new name, and then to the instance variable associated with the object that called that set name, so the name that belongs to me, I am assigning King David to that name. And from then on, as long as me is around, that name is retained. All right. It's pretty common to have a lot of getters for these instance variables that you want other code to be able to know about. And it's pretty common to have setters to change them as well. Now the thing is, you can have more, it's not just always assigning a new value here. You could have like, if age is less, if like, let's say this was a set for the age. You could say if new age is less than 0, then set age equals 0 or something like that. You can have some logic in here to kind of make it so you're only allowed to do safe things that are meaningful to these values. And again, you can protect that data from weird changes from elsewhere. So setters and getters are really just non-static methods. They are common enough in object-oriented programming code. They have their sort of special names, setters and getters, sometimes called accessors and mutators. They access data and they mutate the data. But you can have some general purpose stuff. So I might have a something that's going to answer whether or not a person lives in Utah. And in this case, I want to check whether the stored state is equal to UT. Again, not equals, because that would just see that the reference is the same, but I want to know if the value of the string stored in state is equal to this string here. So this is just like a general, just a general method. And I can print out so I'm going to call from me, I'm going to ask, do you lives in Utah? Does me lives in Utah? I'm trying to figure out what the right grammar is there. If I run it, it says true, because I do live in Utah. All right, so when this object calls this method, it comes up here. Again, I'm not passing in values here. I'm asking the internal stored values in that object about it. So it says, is the string stored in your state instance variable? In other words, the one that again belongs to me. is it equal to this string? And if so, it's true. If not, it's false. So this is more, this stuff is sort of all set up here. We're defining what data is stored in a person object. Here we're defining how we make a new example of a person object, new instance of a person object. These are kind of what we sort of think of as boilerplate kind of stuff, like, hey, if someone else in some other code, how do we actually get that name out of here, right? And so we just return the name. And if we need to change that name, what do we do? Well, we call this set name. And then this is really where the sort of main part of object-oriented, you get through all this setup stuff, and here's you saying, what should this thing do? Well, it should be able to tell whether this person lives in Utah or not. And so we write a method to do it. And then other code just has to ask that question. Hey, do you live in Utah? And it answers, true or false. So I think it's a little bit weird that, we're used to seeing some variable, like it'd be like string name David or something like that. And when it kind of goes away. It's the same thing here. What is the lifetime of me? Me is defined in this scope. When you leave this scope, me goes away. But these instance variables that belong to me also stick around as long as me is also valid, right? So as long as there's a me around, I can get to that name for me and the state for me and the age for me. And it's not like I have to, so one thing is I don't have to pass these values around. I just have to ask that object about them or how to use them. And they persist as a collection as long as this variable still references them. All right, so that's, to be honest, quite a bit of stuff. And it's like 90% of what you need to know for object-oriented programming, but it's the hard part is getting used to working in this style. We've sort of been getting you to get used to working in these little methods that do like one little thing. You pass values in, get a value out. Now we're looking at much larger structures. These classes are very long, right? And you have to look at a lot of it to understand what it does. But it's a nice organizational tool that puts a lot of powerful things together, and it makes it easy for other code to figure out what a person does or how to use it. So again, we'll definitely be exercising this and practicing this, but this is sort of like a big first pass, and I want to show you sort of some basics, and then we'll sort of get used to how it all works together. All right, so we'll continue this over the next few weeks for sure.